Okay, welcome back to the channel. Today we have another U2000. This was sent to me for repair by a friend who said it was working fine. Everything was great, got it all dialed in, turned it on one day and it didn't work. It went from working fine to not working, and so in other words, it's dead. So we are going to see if we can figure out why it's dead, get it repaired, and see if we can get it working. So the first step we're going to do is get it out of the box and do a visual inspection. See if anything's blown, burnt, or what. Maybe check the fuse, but it's never the fuse. These U2000, 7500, 7400, and U5000, these can all catch fire and burn your entire house down, and the only thing that they'll find that has survived is the fuse. The fuse will never blow in these things. I've never seen one blow. It takes an act of God for it to go out. Just putting that out there. It's almost never the fuse. So yeah, let's open this up and we'll inspect it and see what we have going on. Let's make sure there's nothing on here that doesn't need to be shown. He's got his address here, so let's block that out. Okay. U2000 monitor chassis was working, then powered down for evening and never turned back on. Went through troubleshooting for power and everything seemed to be okay, but would not power on. Included a cap kit. But I can install that if need to. Oh, I didn't want to mess with it until it's functional again. Okay, well no, we can get the cap kit installed, that's fine. So yeah, let's see what we have going on. Oh, that's nice. See if we can get this all back in here. The bag was not closed. No big deal. We'll set that aside. Is that all of them? Nope. Okay. One more in here. There we go. Whoa, what the heck? Never seen that before. This out of here. Someone went slightly overboard with their glue for the linearity pot, or coil, I'm sorry, linearity coil. So it's not even seated properly. I mean, the magnet is attached to the coil, so in theory it probably is okay, but it's not seated properly. Somebody went way overboard on the glue. But what has caught my eye immediately is the fact that someone has replaced this C106 with this, I don't even know what this is. It's a capacitor, but it's like it's a filter capacitor, like you see on the ones, REFA, like it looks like a REFA cap. So I don't know if it's a REFA cap or not, but this is going to come out for sure. We're going to put the correct one back in. I don't know what's going on there. That's very odd. Never seen that before, ever. R120 is smashed flat. We don't need the video cable for now, so let's get that disconnected. Set it aside. And, oh man. Typical fashion, we got our resistors here for our color are smashed flat. Have to fix those. I can never get one of these and have the neck board be fine. There's always something wrong with these. And these are all secure. These don't move around, so hopefully our solder joints are good. Let's go ahead and cut this board off of here. Set that aside. Yeah, not too bad. Very low hour U2000, so we should be able to just touch these up and have it be good. Readjust these. So neck board seems okay. I'm not going to adjust the colors because I assume they're going to be set for his tube, so we'll just leave those as they are. But somebody has definitely, that seems, someone has replaced, this is not the right connector. You see someone used a 2-pin or something. And, I mean, it works, but, yeah. Okay, 3 amp, is that a 3 amp? Someone didn't overfuse this, did they? Let's take a look. 3 amp, nope, they did not. And the fuse, of course, is good. It's always good. We can visually check it, though. And I do want to mention here, since we're on the subject of this area, the reason you don't need an isolation transformer with these chassis is because there's already one built in. If you look here, this little guy right here is an onboard built-in isolation transformer, so that's why you don't need one on these series of chassis. There we go. All right, let's turn this on, make sure we have continuity. Always check your leads first. Yep. Yep, good. It's always good. Okay. Another visual. Someone has done the light bulb trick, it looks like, because the W156 jumper is removed, but we'll do it again. And, I'm just looking everything over here. I don't see any cracks in the solder joints for the flyback. There's no cracks on the solder joint for the fuse, or the power connector looks okay. That doesn't look good. Q703. Q703, if this if this transistor is bad, the chassis will not power up. So this looks rather grim. I'm sure that's fine, but where'd my damn... There it is. Yeah, it looks rather grim. Especially this one. But, I mean, they're soldered in. Let me hit those real quick. I'm gonna hit these real quick with some fresh application. All right. Well, I guess what we'll do is we'll go through and do all of our testing. Everything looks okay. We got some... Let's get rid of that. Okay, let's do our testing and see what we find through our normal testing here. Okay. Okay, number 1, HOT. He didn't say it was ticking, he just said it doesn't power on. So let's see if our HOT is good. Where'd you go? Upside down, okay. HOT is good. Voltage, I'm sorry, vertical IC. This should be ground, but that should be the only one. This one here should be ground. We should not have a ground on any. It's pin 6. 1, 2, 3, 4, 5, 6. Yep, so pin 1, 2, 3, 4. No, it's pin 5. 1, 2, 3, 4, 5. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our vertical IC is not shorted. That's good. D603 should read this way, but not this way. That's good. R760 and R765, if those are bad, you could have a HOT blowing, or it could affect your horizontal circuit. So I assume they're good because we don't have a blowing HOT, but those two resistors are this one here. It's hard to see, I guess, in this angle, but it's this one here and this one here. These two resistors are R760 and R765. On the they're not there on the K7400, but they're there on the 5000 and the U2000 and the 75, I think. I can't recall. But you want to check on the U2000 for sure, and the 5000. You want to make sure these two resistors are good. So if we go back out here, R760. One of them I think is around 400 ohms. The other one's 33K. So we got, well, that's odd. I take that back. I think depending on the revision of the board, R760 is either going to be 100 or 400. In this case, it's 100. So I think that's accurate. If yours reads 400, then that's also correct. It should be 100 or 400 depending on the revision of the chassis. But 765, I think, is supposed to be 33K. 3.3 megohm. That, I think we just found our problem. 3.3 megohm. That is not good. I've got another U2000. Let me grab another U2000 here, and we'll do some comparative readings here. Hang on one second. All right, so I have here a known working, rebuilt U2000. So let's read 765 on the known working one. $33K and 760. There's the 400, like I said, 473. So something is bad on this. We can take R765 out and replace it. We'll test it out of circuit, but that's a good reading on R765. Should be 33K, and I think it's 100 or 400 depending on the revision. There's 473, so we may have two bad resistors, but I can't say that that is the issue, but that is definitely an issue. So we'll set our good one aside again. All right, so let's take that resistor out and see what it reads out of circuit. Let's grab. I can't help you, Worf. You're welcome. Okay. Turn my fan on. 765 is this guy here. Let's take out this leg. All right. We now have 765 out of circuit. As you can see, it is now removed from the circuit. And let's read what it shows out of circuit. Oop. Nobody ever told her it's the wrong way. All right, 765, what do we get? Open. 765 is open. Do we read the same 3 point something megohm on the pads? We do indeed. So we have an open 765. Let's check 760 with that out of circuit. Still 100 ohms. I'm skeptical about that. Let me... I've got more junk down here. Hang on a second. That's see on the K7400, no 7500, 760 and 765 aren't there. So it looks like it's the U2000 and U5000 only have those two resistors. And I think I've got, here we go. Here's a donor 5000. And we have our 760 right here. And our 765. So let's get those swapped out. Or at least read them. So apparently the 5000 and the 2000 are the only two that have these two resistors. So let's take a reading off of our 5000 here. And in theory it should be the same. If this reads 400, I'm going to take both of these out of here. Okay, so R765, 33K, 760, 264. Well, that seems to be in between 100 and 400, so I'm going to steal both of these and put them in here, and the other in our suspect chassis, and then we'll keep testing. If we find nothing else wrong, we'll fire it up, see what happens. Okay, put that back. Let's go ahead and I'm going to remove this from here. I'm going to remove this from here. Okay. What's odd though is usually when R765 or R760 go out of tolerance, the HOT gets taken out. But so I don't know if we're going to find something else wrong. We may, but at least we found one of, if not the problem. So I'm going to go ahead and disconnect our neck board here just so it's not in our way. There we go, set it aside along with our remote harness. Alright, so let's grab 760 out of here. And I think I'm 99% sure that certain revisions of the board have a 100 ohm R760. But I'm going to put the one over here that's from the 5000 that reads 264. That's in between the 400 and 100. So I'm more confident with that one in there than this, because this looks like somebody has replaced this in the past, because it shouldn't be sitting that high up off the board. Alright, so there's our two resistors. Put those out of the way. Let's... Normally I'd use the desoldering gun, but I don't want to wait for it to power up just to suck up 4 pads there, so... Where'd my damn trash can? There it is. Alright, so let's steal these out of this donor 5000. That is not my donor 5000. Here we go. Here we go, resistors. Here we go. Okay. Louie, 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 Louie. I get a copyright strike. Louie, 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 Louie. Louie, Louie, you're gonna die. Alright, there's 760. That one is excessively long there. Alright, 760. Let's transplant that so we don't get these mixed up. 760 goes in here. All right, 765. Goes, oh, this is gonna be fun. There's 765. Let us pray that this works. We got a lifted pad there. So let's see if we can massage this over to the right spot. Success. All right. Are those all supposed to, I don't know what's going on there. Looks like somebody has got a bit too close with this. Let's check that transistor. All right, so we're going to check this transistor here, Q708. Q708 is also an HOT killer, but this transistor could be bad. It could have taken out these two resistors. So let's check this Q708. 157. All right, so I think that's good. So there's our voltage drop for the internal of the transistor. And then we got 1.5. So let's check that against our other one. Do we have continuity here? Yes. Yes, and yes. So all of our continuity is good. However, I don't like this. There we go. I just put a little bridge across there because that pad was lifted for R760. So I put a little bridge there to I think that's the collector. I think it's base collector emitter. I can't, I don't think it says, but anyway, yeah, again, if we go to our middle one, whichever is collector or emitter, and we go to diode mode, there's our 0.589 and our 1.4. And then of course if we go here to here, we should get our 33K across this one. No, this is the 261. Yeah, and then this one should be 33K. Well, there we go. It'll climb back up in circuit here. 26 point, 27 point, 28K. So, yep, our Q708 appears to be good. We have good continuity to our 760. 765 is good, 760 is good, so I think we're all good there. Let's check to make sure that Q708 didn't take out those resistors. I don't think it did. We'll test it against this same one here. Alright, that is this guy here. This is our middle. There's our voltage drop and 1 point. Wait a minute, that goes to open. Let's check our working 74, or I'm sorry, our working 2000. So here's our working 2000. Let's see what 708 does on this one. .6. And 1.6. Hang on a second. Yeah, there we go. 0.6 and 1.5. Okay, so Q708 is definitely good. Okay. So, I don't know why those would have got taken out, but it's very common. That's why I went to them. So, yeah. All right. We can... R732 here looks kind of haggard. If we look at it, that doesn't look good. Let's test that. Should be 2K, 2.2K, 2.2K. Well, let's continue on with our testing just to make sure. It could be a capacitor problem that caused this, but let's continue testing, see what we can find. Okay, so vertical IC we know is good. And we know our D603 is good. We found our problem with R765 and 760. We know Q708 is good. We know Q703 is good. We know our HOT is good. If we had any problem here with these diodes or polycaps that are in here, our HOT most definitely would have gone, so we can assume that our polycaps are all good, and our diodes in here. We can test R303, which is for our vertical, to make sure vertical deflections, to make sure we don't have any collapse when we turn it on. That's going to be 1.2 ohms, give or take. 1.3, that's perfect. D303, or I think it's D302, sorry, D302 is this guy down in here. This guy right here. That's also going to be responsible for vertical deflection. And it is good. Okay, let's test our voltage regulator. It was a clear black night, a clear white moon. Yeah, 1.0, other leg should be our voltage drop. That's correct, voltage regulator is good. R104 should be 10K ohm. 13K, that's not out of the realm of normality. So I want to change this C106. I don't know what it, obviously it was working with it in there, but this is not the right type of cap that should be in there. So we're going to change that. But before we do, let's test our switch mode power supply chip. We should have, this should be our, with negative, there's two middle pins here. Let's zoom in a bit. There's two middle pins here, and then an outboard and an outboard. Between this middle pin and here should be a voltage drop. Oh, sorry. Yep, between this middle pin and this outside pin should be a voltage drop. Yep. However, it should be in the 0.6, not the 0.5. That's an odd reading. It should be, like if we go to this one, and I do the same thing here, it should be in the 0.6 range. No, I guess not. I thought it was. No, okay, well. So now we know that's good. We'll test it again real quick. There's our 0.5. Oh, wait a minute. See, now it's 0.6. I don't know if I didn't have a good, I must not have had a good connection on there. That's, no, I had the leads backwards. It's been a long day. I went to Kansas City and back to pick up a machine, a Nintendo Super System, and it's been a long day. So here we go. Let's go back here. Middle pin to the outboard pin, 0.5 voltage drop. Then this middle pin to the outside pin here, 0.6 voltage drop. This should be, I think, 1.0. Same, read it the same way, or 1. One of these is 1.0. Other set's 1.7. There's our 1.7. But this should be 1.0. Again, if we go to our working one and we do the same thing, 1.5. Am I losing it? Am I losing my mind? I swear to God. Maybe it's different on the 2000. You know, the 7400, 7500, 2005, they're all slightly, subtly different. And I may be remembering incorrectly. I may be remembering on a different one of those. But I guess the whole point here is to make sure that it's not shorted. And we've verified our readings are the same as the other one. So I guess that's okay. It doesn't look very good, so I'm going to reflow this. That's better. All right, I think that's about it. I'm going to change this capacitor, and everything else tested good. I'm going to reflow this. Is that down in there far enough? Yep, okay. Let's change this capacitor out. It's odd that it's got this factory looking glue type of setup. Maybe somebody did this when they installed it, but you know, usually the factory glue is white like that. The factory glue is white, so I think someone did this because the cap went out and they didn't have the right type. So let's take this out of there and put the right kind in there. So there's that. Won't you flow, 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 pancreatic juice, flow, flow, into the duodenum. Won't you flow, 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 pancreatic juice, flow, flow, into the duodenum. Throw that away. Let's snag the correct type of cap, which is going to be this guy here. It's a poly cap. Does he have that? No, that's different. That's going to be a ceramic cap, not a poly cap. Someone's done the same thing on here. They have replaced the ceramic cap with a poly cap. Do I have this cap on the 7400 here? Oh, I do. This is what's supposed to be in there. This guy right there, this film, this metal film capacitor. So let's, or a ceramic capacitor, however you want to refer to it. So let's take this out of here. Come on, ground plane, let go. There you go. Oh, that one's broken a bit. It'll still be good. All right. So let's toss this in here. Can I get rid of this glue? Yes. Achoo! Oh, oh. Okay, so let's install this here. Bada bing. So there we have it. I think we're ready to go ahead and just hook it up and test it and see what we get. Let's put that there. Set this aside again. And if it powers up, we'll make sure our B plus is set correctly. Looks like somebody has replaced the pot, so hopefully it's set properly. So if it does power up, we'll make sure we set our B plus correctly. And then we'll do our cap kit and make sure it works again after that. And call this a successful repair. Well, I need to do, when I do the cap kit, I will of course readjust all this jazz here. So, because right now we've got these two transistors are dangerously close to the heat sink, so we don't want that. And they're all pretty much touching the resistors, and we don't want that. So yeah, when it comes time to do the cap kit, I will fix that. So let's make sure we plug in our remote board. I don't see any broken pots. Get this plugged in. I think we checked everything. We should be good. Let's make sure we don't have any broken header pins on our remote board. Don't see any. That's part of the normal reflow that I do when I do this stuff. Okay, remote board's plugged in. Everything else is secure. Let's get this hooked back up. Let's get this back in here. Alright, let's get it plugged back onto the board. Alright, let's grab a picture tube, see what happens. Uno momento, por favor. Okay, we're all hooked up. Anode, neck, yoke, ground, video, power, and remote board. And I have the B plus set to go to the test point 202 right there. Maybe you can, let me take this out of there. There's a little test point 202 right there. It says B plus. We want to hook to that. And we have our ground. Oh, let's go back out, sorry. And we're isolated so we don't touch anything like the metal frame. And we have our ground hooked up and we're ready to read volts DC. We have our remote board. So let's find out. Did we resurrect this by changing a couple of resistors? And possibly a cap, but I don't think that was the problem. I think the problem was obviously R765 was open. But of course, one of these other things could have been a contributing factor, but I don't know. Let's see. 1, 2, oh, I gotta turn this on. 1, 2, 3.
It works! It worked!
117.3. Do we have an image? Yes, we do. Tired old tube. Move it to center. Contrast. Dear Lord. Right there. Brightness. Yeah. Nice. Width. Let's go there. A little smidge more, and each position just slightly more this way. Yep. All right. Full deflection, height and width, so that's good. Let's go down. Each position, bring it down a bit. Oh, sorry, vertical position. Like I say, been a long day. Vertical position, down to there. Adjust our height back. Perfect, beautiful, square image. Hot dog. Well, there you go. We had an open R760. R765. In an open R765. And a possible out of tolerance R760. But I think that you can have a 100 or a 400. So I think by just putting that one that was 264 in there, it just, covers both bases. I don't think this was actually a problem, but it could have been. And of course, we changed out this weird cap that shouldn't have been in there. So I'll let it run. Actually, you know what? No, I won't let it run. I'm going to take this off of here and do the full cap kit and do the full reflow. And I'll come back and we'll test it one more time and call it good. So stand by. Okie dokie. Just like that, full cap kit's installed. There's all the old caps plus our bad R765 and possible bad R760 and possible bad, what was that, C106 something or other. But we know for a fact it was not powering on because of the bad R765. We got all the caps changed out, the other possible bad components, and it is ready to go, including the filter cap. The filter cap was replaced as well. So let's turn on our test pattern generator and make sure I didn't put something in backwards or bridge a joint. I should also mention that everything has been, all the normal problem areas have been fully reflowed, as well as anything and everything that looked like it might have needed reflowed, as well as I did all the work on the neck board, straightened up the resistors, I straightened up the heat sinks, and I actually moved the resistors and inductors away from the heat sinks, so now they're not in direct contact, including the transistors here, so that's all good and squared away. And yeah, everything's should be good to go. Let's we got this turned on. Let's see if I did anything wrong here. 1, 2, 3. Hey, all right, power's up. It's probably still too early to call. No, we're not seeing any smoke, nothing popping. Do we have an image? Yes, we do. And it's not too far off from where it was. It's actually just the same. So that goes to show that pretty much none of these caps were actually bad, because there's no difference in position, there's no difference in size. Everything is still the same, so we can pretty much say that all those caps were actually probably pretty good. But there's no harm in changing these out anyway, so yeah, there you go. Another one resurrected. All that was wrong with this was a bad R765. And again, maybe R760, you know, we've gone over that before, but anyway, yeah, so quick and easy repair. Thanks for watching. Hopefully you learned something. Stay tuned. I got more stuff in the works when I can get to it. I appreciate you watching. Like, share, and subscribe, and we'll see you next time.